this is the final chapter of this book right here, Causal Inference in Statistics. And we're in chapter 4, which of course is dealing with counterfactuals and different applications of counterfactuals. And so we've gone through, some applications already. And then we're going to hit something that's going to be, I don't want to necessarily say difficult, but is apparently requires enough background information that the book really kind of skims over it. And so I'm going to try to do my best to provide some of that background. And in doing so, in addition to working through the questions here in Chapter 4, I'm also working through the examples that are provided. And so in the next few videos, before we get to an actual question way down here, we're going to look at some of these examples. And the first two that we'll look at, 4.43 and 4.44, will link up with 4.51, skipping 4.45, and then all of that will link up with the question 4.51. And example 4.45 will deal with the questions that come after question 4.5.1. So I'm not sure what order I'll put these in the playlist. Probably I'll just put them in the order they're presented in the book, but this just kind of gives you a heads up about where all of this is going. And then also, this example as well as example 4.44, and a little bit 4.45, they aren't, they're just presenting ideas. They're not really working through anything. But when we get to 4.5.1, we will work through something that is really rather involved. So this is really, so these two videos really are just an introduction to example 4.5.1, and there's going to be a brief interlude maybe for example 4.45. Sorry for that long preamble. Okay, so example 4.43. So we have two people, two women, Ms. Jones and Mrs. Smith, and they both have, must be breast cancer, and they're presented with two options. Either they have a lumpectomy, which I believe just means surgically removing the tumor, or lumpectomy plus radiation. Okay, and so they both make their decisions, and Ms. Jones decides to go with option 2, lumpectomy plus irradiation, and Mrs. Smith decides just on lumpectomy alone. And after some time, after 10 years, Mrs. Jones, or Miss Jones, has no recurrence of the tumor. But and again, Miss Jones had lumpectomy plus radiation. Mrs. Smith, on the other hand, who only had lumpectomy, has a recurrence. And so in both cases, these two women could ask, is this outcome due to the treatment that I chose, right? So in other words, Miss Jones could say, what in the counterfactual scenario where I only had lumpectomy, would I have had a recurrence? Okay, and conversely, Mrs. Smith, again, who only had the lumpectomy, could look back and say, should I have also undergone radiation? Would that have prevented this recurrence, right? And so in both cases, we're dealing with these counterfactuals. Okay, and so like I said, this example is really just used to present these ideas of the probability of necessity and the probability of sufficiency and the probability of necessity and sufficiency. So we'll just go through these here right now. So maybe the first thing to say, at least for probability of necessity and sufficiency, is really what these are doing is they are just simply constructing these counterfactuals, having conditioned on whatever set of conditions. Okay, and so so the probability of necessity and sufficiency would just be certain combinations of things that we're conditioning on and outcomes that we're looking at that are interesting. Okay, so in other words, we could get creative. Like there may be special situations where we want to condition on something else that happened and look at a different, a different potential outcome, et cetera, et cetera. But yeah, so But in the case of the probability of necessity, okay, so what are we asking here? The probability of necessity is asking, what is the probability that an event would not have occurred, in other words, y equals 0, if a specified exposure did not occur. In other words, the counterfactual value for x prime equals 0, given that we observed that the event did occur and the exposure occurred. Okay, so take your time to work yourself through that, but there it is. Now, like I was saying, so the things that we are conditioning on, we could add to this, and so we might generically instead say that that probability of necessity is something like this expression, where we are just making it generic, where z equals little z, where little z may include such things as x and y. Okay. Okay. Now, for the probability of sufficiency, we're asking something different. Okay. So we're asking, what's the probability that an event would have occurred? In other words, y equals 1 here on the left side of the conditioning bar, if a specified exposure did occur, so counterfactual value of x equals 1, given that that the event did not occur and the exposure did not occur. Okay, and so once again, I think that we could more generically write this as conditioning on z, where z includes x and y, and so on and so forth. Okay, and then finally we have the probability of necessity and sufficiency. All right. So the book kind of gives us this expression. So it is a joint probability expression, the probability that y equals 1 when x equals 1, the counterfactual value for x equals 1, and y equals 0 when the counterfactual value of x equals 0. So in other words, the x1, y1 part is the sufficient condition, okay? And then the other part here is the necessary condition. And so you can go back through and look at those arguments up here to decide that, or to hopefully make sense of why that's sufficiency and why that's necessity. Okay. And I think that we'll just jump into example 4.4.4 because it is just dealing with probability of necessity here. Again, it's not working through anything. It's just presenting a way of applying some of these ideas here. Okay, so here's the setup. Okay, so Mary files a lawsuit against a New York-based firm. Okay, alleging discriminatory hiring practices. Okay. So her case is that she applied for a job with this company, and that she's qualified for it, but was not hired. And she suspects, or she alleges, and let's take her at her word, that the reason that she believes that there was some kind of discrimination taking place here is that she is gay. So she also cites that apparently the company shows some preference for straight employees, for non-gay employees, or whatever. So that's the case that she's making here, and you can the question is, does she have a case, and is there a way to demonstrate any kind of discrimination in the hiring practices of XYZ International, of the company? Now, we're not here to try to adjudicate this case, but we are just simply meant to recognize that really what we're being asked for is one of these counterfactual operations, that we've learned about here, and so the idea that we want to pull on is the probability of necessity. Okay, so we're being asked, what is the probability of a person being hired? Y equals 1. In the case that they are straight, counterfactual value x prime equals 1, given that they were not hired and are, or at least perceived to be, gay or not straight, x equals 0. Okay, so that's all that example is doing there. Okay, I think that we will take a break here and then do example 4.4.5 and then launch into to the complicated 4.5.5.